Myself, Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today I am going to discuss about some problems on grade, divergence and curl of a scalar and vector point function. Some problems depend on a scalar point function and some problem depend on vector point function. If we find out the grade of a scalar point function, grade depend on a scalar point function, but divergence and curl, both value depend on vector point function. So today I am going to discuss about some problems on these topics: grade, divergence and curl. So first of all, I want to discuss about some definition of grade, divergence and curl. I have already discussed these three topics in last lecture, but very elementary introduction I want to give here. Some problems on grade, divergence and curl of a scalar and vector point function. So point 1 is concept of grade of a scalar point function. Grade, if we find out the grade, then we have to must, that is very compulsory, there should be a scalar point function. A scalar point function means in three-dimensional geometry, the position of a particle is represented by only function, only scalar function, which is dependent on three variables x, y, z. So there is only function this type x, y, z. This is known as this is the position of a point. This is the value of the function at some position of a point on coordinate system. Value of the function at the given point in a coordinate system. Suppose there is any point P in a coordinate system and the position is x, y, z, then the value of the function there at this point is function f x, y, z. So this function is known as a scalar point function. There is no vector in this function. And we find out the grade, then we take this function, a scalar point function. So in grade of a scalar point function, there should be two main components which are given as below. Number one, function x, y, z. This is a scalar point function. Number two, del. This is three-dimensional differentiation vector operator. Then operating by del, to given a scalar point function, we get divergence of a scalar point function. So grade here, grade of a scalar point function, sorry. So here grade equal to grade f, this equal to del f. Okay, f is scalar here, f is a scalar. F is a scalar here. Now, concept of divergence and curl of a vector point function. What is concept of divergence and curl of a vector point function? First of all, I want to tell you in both problems, divergence and curl, there should be vector point function. Vector point function is common in both divergence and curl. But in divergence, there is dot product between vector point function and del. Both are vector. Del is also vector and f is vector point function. So here we are taking dot product then we get divergence of a vector point function. Point 2 here, concept of divergence of a vector point function. So here I am giving some introduction about this divergence of a vector point function. In a divergence of a vector point function, there should be two main components which are given as follows. Number 1a, f is a vector point function. F is a vector point function. F vector, this x, y, z, and this equal to f1 I plus f2 j and plus f3 k. f1, f2, f3, these three are components of the function along x-axis, y-axis and z-axis. So, and del is a three-dimensional differentiation vector operator. Then dot product between these two vectors, vector function and del, is known as a divergence of a vector point function. We note here f is vector and del is vector. So we apply here formula del dot vector f. This is divergence f. Divergence f vector, this equal to del dot f vector. Okay. What here del is three-dimensional differentiation vector operator with respect to x, y and z. So we should have knowledge about the order of dot product. What is order? We should apply correct dot product here. So here del dot f. Del is differential operator with respect to x, y, z. So we writing here del is first and vector point function f vector is second. So del dot f is known as a divergence of a vector point function f. So divergence of vector point function f equal to del dot f. So what is the value of del? Del is three-dimensional vector I cap dou over dou x plus j cap dou over dou y plus k cap dou over dou z. This is the value of del. This is a three-dimensional vector differentiation operator. So this is the value of del and this function f. So this is the value of del and this is function f. Three-dimensional vector function f1t I, f1 x y z and f2j, not t here, f1i plus f2j plus f3k. After taking dot product, we find this. Here we apply formula I dot I, this equal to 1 and j dot j, this equal to 1, k dot k, this equal to 1 and I dot j, this 0, j dot k, this 0 and k dot I, this also 0. Basically these 6 formulae we are apply here. So after taking dot product between del and vector point function, this equal to del f1 over del x, dou f1 over dou x plus dou f2 over dou y plus dou f3 over dou z. This is correct formula. But if we are taking dot product is vector function f and dot del, then this is wrong formula. This is incorrect formula. Because del is differential operator. So del taking first here, then del differentiate to the function with respect to x, with respect to y and with respect to z. So we get this del f. Formula is this. Now next, concept of curl of a vector point function f vector. What is curl? curl of a vector point function. So in curl of a vector point function, there should be two main components which are given as follows. Number one, f vector is a vector point function. F vector equal to here f1, this is the function of xyz, f1i plus f2 xyz and j plus f3 xyz and k. Okay, this is vector point function f, and here is f is vector, this is xyz, f vector, this is resultant vector, this is vector along x-axis, this is along y-axis, this is along z-axis, this is the component of the function along x-axis, along y-axis, along z-axis. So this is the vector point function. This is very must to find out curl of a vector point function. And this is del. Del is three-dimensional differentiation vector operator. Then taking cross product between these two vectors, f vector and del vector, is known as a curl of a vector point. So here curl f vector equal to represented by del cross vector f. Del cross vector f. This is cross product. This is vector product. Cross product is known as a vector product. This is always a vector. Curl is always a vector and divergence always a scalar. So curl f equal to del cross f, and del cross f represented by a determinate. In determinate, in first row we are writing ijk. Ijk are unit vectors along x, y, z, and second row is dou over dou x. This is the coefficient of I in del. Dou over dou y and dou over dou z. This is the f1, f1x, f1 and f2 and f3. These are the function of x, y, z. So this is known as a curl f. Now finally I am giving only 3 points here very shortly. Number one, grade f. Grade f. Grade f means del f. Here f is scalar. Here f is scalar. F is scalar. Number two, but this is vector quantity. This is vector quantity. Vector quantity. Number two, divergence f. Divergence f, del dot f vector. So this is f is vector. F is vector point function. Vector point function here. But this is scalar quantity. Scalar quantity. And third point is curl f. Curl f. So this is del cross vector f. Here f is vector point function. Vector point function. Vector point function. But this is vector quantity. Vector quantity. So this is first vector quantity, last vector quantity, and second is scalar quantity. Divergence always a scalar quantity. Grade f is always a vector quantity. Curl f always a vector quantity. So these are the main concept between these three points: grade, divergence, and f. So now today I want to solve some problem based on grade, divergence, and curl of a scalar and vector point function. Vector point function means r. R is the position of a point in the coordinate system. and vector r. This is in vector form, this is in scalar form. So where vector r is xi plus yj plus zk. I have already tell you about this. This is x-axis, this is a point, this is origin, this is z, this is y. So this is a point, OA, this is x value, and here is I vector. This is V, AB, this is J vector, and this is Y value, and here is P point. P is this point. This is Z value, and here is K vector. OP. P is the X, Y, Z. So here OP is equal to vector OA vector plus AB vector plus BP vector. So OA is X, this I, plus AB is Y, and this J, plus BP is Z, ZK. So OP is R vector. This is the value of vector R. Now, modulus of R vector. Modulus of R vector, modulus of R, that is converted in scalar. Modulus of R vector means x का square, I का coefficient x. So x square plus y square plus z square to the power half. This is the scalar point function vector. Now, I want to solve just now a problem which is based on divergence of a vector point function. This is problem depend on divergence, not curve. This is divergence, vector point function. So this is very most important problem and very interesting problem, also very easy problem. So I am solving this problem slowly and discuss about every formula which applied in this problem in detail. So problem 1, if R is vector point function xi plus yj plus zk, this is given in our question, then prove that del square r to the power n, r is scalar here, r is, if there is not vector mark on r, that is scalar. If mark vector on r, that is vector. So r to the power n is scalar quantity and vector r. Del square of r to the power n vector r equal to, prove that this result, n into n plus 3 r to the power n minus 2 into vector r. So this is very most important problem and we want to solve. So solution start here. If given us that r vector is this xi plus yj plus zk, this is vector r, then we know that r, what is r? R is under root x square plus y square plus z square, and r to the power n equal to x square plus y square plus z square whole to the power n by 2, and r square equal to here x square plus y square plus z square. This is r square, this is r to the power n, this is only r, and this is vector r. If vector r given here, so we are taking mod of this vector. Modulus of vector means mod of r. Mod of r means scalar r. Scalar r equal to under root coefficient of I का square, coefficient of j का square, coefficient of k का square. So here x का square plus y का square plus z square square. So r equal to under root x square plus y square plus z square. Squaring on both sides, then we get this result. R square equal to x square plus y square plus z square, and r to the power n is x square plus y square plus z square to the power n by 2. So these all properties we are applying in the question to find the solution. Number 1, first we will find the value of del r to the power n vector r. In our question is del square r to the power n into vector r. But first we find del, then again taking dot product with del, then we get del square. So here del dot r to the power, here del r to the power n vector r. This is given in our question. I am taking 1 power of del. In our question is 2 power of del. So here del r to the power n vector r. Number 1 del is vector here and r vector r here. So both are vector. Then there is dot product between two vectors. So we applied del dot r to the power n vector r. This is equation 1. Putting value of del and vector r in equation 1. Putting value of del and vector r in equation 1, where del is this I dou over dou x plus j dou over dou y plus k dou over dou z, and r is vector xi plus yj plus zk. Both value putting in equation 1. Then we get here del r to the power n vector r. So value of del this I dou over dou x plus j dou over dou y plus k dou over dou z into r to the power n, and this is the value of r xi plus yj plus zk. R to the power n is same, not putting value of r to the power n in x, y, z. If I am putting the value of r to the power n in x, y, z, then problem will be very difficult. So this is very easy. No change this function r to the power n. Putting value of vector r. Now multiply this r to the power n to this side bracket. Then we get this is same value of del. I am writing here I dou over dou x plus j dou over dou y plus k dou over dou z. This is the value of del and dot r to the power n multiply to this bracket. R to the power n into xi plus r to the power n into yj plus r to the power n into z vector k. This is equation 2. Now taking dot product between two vectors, first is del and second is this. This is second vector and this is first vector. Taking dot product. Taking dot product between two vectors, first is del and second is this vector. This is given in our question. But first of all, we find out the first degree of del. So here and here we using formula I dot I is 1, j dot j is 1, k dot k is 1. This is equation 3. I dot j equal to 0, j dot k equal to 0, k dot I equal to 0. These are unit vectors. I, j, k are unit vectors which are at right angle to each other. I and j at right angle, j and k at right angle, and k and I is at right angle. So the dot product between these vectors, different vectors, is always be 0 because the angle between these vectors I and j is 90 degree. So we apply here formula a dot b, vector a dot vector b equal to a mod and b mod and cos of theta. Theta is 90. Theta is 90. So this result is 0. Then we get putting these value in equation 2. Then we get this del dot del r to the power n vector r equal to here I dot I. Dot product between I dot I is 1, but I dot j is 0. I dot k is 0. Similarly, j dot I 0. J dot j is 1. And k dot I is 0, k dot j is 0 and k dot k is 1. So only multiply between I to I, j to j and k to k. Other elements are 0. Other terms are 0, in which the vectors are different. Dot product between different vectors in a term, that term will be vanished. And dot product between the same vector in a term, that term we get. So we get here dou over dou x r to the power n into x, and dou over dou y r to the power n into y, dou over dou z r to the power n into z. This is equation 5. Now we differentiate this function with respect to x partially, but in this function there are two functions. First function is r to the power n and second function is x, and there is multiply. So we are using here product formula for differentiation. So what is product formula? This equation, same equation 5, del r to the power n vector r equal to dou over dou x r to the power n into x plus dou over dou y r to the power n into y plus dou over dou z r to the power n into z. This equation 5. Differentiating in each term, term 1, this is 1 term, this is 2 term, this is 3 term, with respect to x, y and z respectively, by product formula in each term. Then we get, what is formula? Formula is differentiation of u into v. Here u and v are two functions. So u and v, differentiation of u and v, we apply product formula. U is constant, differentiation of v, plus v is constant, differentiation of u. Same formula apply in each term. There are 3 terms in our question in equation 5, and we want to differentiate each term with the help of product formula. So here using this. Now here is second function is x taking here constant. Second function constant, differentiation of r to the power n. R to the power n, differentiation with respect to x to r to the power n. Plus, first function is constant, r to the power n. Differentiation of x with respect to x is 1. Plus, next second term, y is constant, second term y constant, differentiation of r to the power n with respect to y, and plus r to the power n constant, differentiation of y with respect to y, that is 1, plus z constant, third term, second function is z, so z is constant, second function constant, differentiation of first function r to the power n with respect to z, and plus r to the power n first function constant, putting first function constant, differentiation of second function z with respect to z is 1. So now here, this equal to x, differentiation of here dou over dou x of r to the power n. So here we apply formula n r to the power n minus 1. This is the, here we apply power formula, and again differentiating of r with respect to x. So here dou r over dou x. This is the total differentiation of r to the power n with respect to x. So we apply here formula this, x n r to the power n minus 1 dou r over dou x, and plus r to the power n into 1, plus next y n r to the power n minus 1 dou r over dou y, and plus r to the power n into 1, plus z into n r to the power n minus 1 dou r over dou z, and r to the power n into 1. Now we know here r square equal to x square plus y square plus z square. So differentiating this with respect to x, y and z. So we apply here 2r dou r over dou x. This equal to 2x. 2 is cancel. So dou r over dou x. This equal to x y r. we find this value. Dou r over dou x is x y r, and dou r over dou y is y y r, and dou r over dou z is z y r. Similarly, we can find value. So now this is the same equation. Here we see that in last equation r to the power n is this, r to the power n is this, r to the power n is this. So r to the power n is 3 times after adding this plus this and plus this. Then we get here, now we write here 3r to the power n. That is same term in this term, r to the power n is same in each term. After adding, we get 3r to the power n plus x n r to the power n minus 1 dou r over dou x plus y n r to the power n minus 1 dou r over dou y plus z n r to the power n minus 1 dou r over dou z. We know that we have discussed this last, r square equal to x square plus y square plus z square. This is equation 7. Now differentiating equation 7 with respect to x, y, z respectively, then we get 2r differentiating r square with respect to x, r square with respect to x, dou over dou x of r square. So what is formula here? 2r and dou r over dou x. This is formula. First we apply here formula of power, x to the power n and x to the power n minus 1. So we are writing here 2r and r to the power 2 minus 1. 2r. Again differentiating r with respect to x. So we get dou r over dou x partially. Y, z are constant here. So we get here 2r del dou r over dou x equal to, in right hand side, x square, differential of x square with respect to x is 2x. Y and z are constant. So differentiation of y and z is 0. So here 2 is cancelled. We get r dou r over dou x equal to x. This dividing by r, then we get final dou r over dou x equal to x y r. Similarly, we write here dou r over dou y equal to y y r and dou r over dou z equal to z y r. Similarly, we find this value and this value, and first value is this. Putting value from equation 8, this is equation 8, in equation 6, then we get equation 6 is this. This is equation 6. So now 3r to the power n, x and r की power n minus 1. This is equation 6. Now putting value 3r to the power n plus x and r to the power n minus 1. And this is the value of dou r over dou x. Dou r over dou x means x y r plus y n r to the power n minus 1. This is y upon r. Dou r over dou y. Dou r over dou y is y upon r. Dou r over x upon r, dou r over dou y, y upon r, and dou r over dou z, this is z upon r. This value putting here. So here I am putting x y r plus y upon r plus z upon r. So here x is x square. 3r to the power n, x into x is x square. And r to the power n minus 1 here and 1 upon r. 1 upon r means r to the power minus 1. So this adding here n r to the power n minus 2 plus y into y, y square, and n r to the power n minus 2. This r is upon r and n minus 2 plus z into z, z square, and r to the power n minus 2. This is r to the power minus 1 adding here minus 2. So we see that in equation this n r to the power n minus 2. This is common in each term. So now 3r to the power n plus nr to the power n minus 2 is common. And next bracket is x square plus y square plus z square. So this is r square. I have already told about this expression x square plus y square plus z square is r square. So putting, we know that r square is x square plus y square plus z square. Putting in equation 9, then we get 3r to the power n plus r square and r to the power n minus 2. So this 2 and this 2 is cancelled. Then we get 3r to the power n plus nr to the power n. R to the power n is common. So n plus 3 r to the power n. This is equation number 10. We find out here value of del of r to the power n into vector r. But in problem, we will find the value of del square r to the power n into r. This equal to n into n plus 3 r to the power n minus 2 vector r. Now taking left hand side is del square r to the power n in r. This is our problem. This value is given in our question. Del square r to the power n into vector r. This equal to del square we can write del and del 2 times. So del r to the power n into vector r. This is equation 11. But from equation 10 we have del r to the power n vector r equal to n plus 3 into r to the power n. This is equation 10. We have already proved this line. This line already proved. Putting in 11. This value putting in 11 equation. Then we get here del and del square n plus 3 r to the power n. This is equation 12. Putting value of del in 12 again. So del is this n plus 3 r to the power n. N plus 3 is common. This is constant taking out and multiply by r to the power n in this vector differentiation operator. Then this function is differentiate with respect to x, y and z respectively in each term. So this is here dou r to the power n over dou x plus j dou r to the power n over dou y plus k dou over dou z r to the power n. Now differentiating this here, n plus 3 is common. Differentiating dou over dou x of r to the power n r to the power n minus 1 and dou r over dou x. Now this n r to the power n minus 1 dou r over dou x x y r. So this value I am putting here n r to the power n minus 1 dou r over dou x plus j n r to the power n minus 1 dou r over dou y plus k n r to the power n minus 1 dou r over dou z. Now n plus 3 is constant and common. So putting value of dou r over dou x. Dou r over dou x is x y r. Dou r over dou y is y y r. Dou r over dou z is z y r. This value putting here x y r and y y r and z y r. Okay. So r is here 1 upon r to the power minus 1. Then n plus 3 here I x n r to the power n minus 2 plus j y n r to the power n minus 2 plus k z n r to the power n minus 2. Here we see that in each term n is common. So n plus 3 into n. Here r to the power n minus 2 xi remaining terms is xi plus yj plus zk. This is vector r. This is vector r. So we get here n into n plus 3 r to the power n minus 2 into r. So finally we have proved this del square r to the power n into vector r. This is equal to n into n plus 3 and r to the power n minus 2 n into vector r. So this result is proved here. Okay. This problem is very important problem and very interesting also. And now problem 2. if R is same vector, this R vector is equal to xi plus yj plus zk, then prove that curl R to the power n vector R equal to must be 0. This is also very important problem for engineering classes. Curl, this is curl in bracket R to the power n. R to the power n is scalar. This is scalar quantity. And vector R is, this is vector xi plus yj and plus zk. So now curl R to the power n into dot vector R equal to 0. We have to prove here this result must be equal to 0. So taking left hand side, del curl R to the power n vector R. Curl means cross product between del. So this is vector and this is curl. So del cross of this function, vector point function. This is vector point function taking cross product between these two elements. This is three-dimensional differentiation vector operator and cross. This is vector point function. This is equation 1. Putting value of del and vector R in 1, then we have, this is the value of del. This is the value of R to the power n is no change. We are not putting the value of R to the power n, but putting value of vector R. This is vector R. So now cross product, this is del and multiply by R to the power n inside the bracket. Then here x R to the power n, y R to the power n and z R to the power n. This multiply here and multiply here. Okay. So now here is cross product. Here is taking cross product. Cross product always known as a vector product. And this quantity known as a vector quantity. So now, how we can find vector product? Curl R to the power n into R vector equal to. This is represented by determinant. In determinant in first row, we are writing I, j, k. 3 unit vector in first row. And second row, dou over dou x plus, dou over dou y plus, dou over dou z. In del, dou over dou x is the coefficient of I, dou over dou y is the coefficient of j, and dou over dou z is the coefficient of k. And this function, this is the coefficient of I in given vector point function. This is the coefficient of j in vector point function. This is also coefficient of k in given vector point function. Now, after solving this determinant, we get, first of all, taking first row and first column, eliminate. Eliminate first row and first column. Then multiply this to this. So here dou over dou y, I is common. I vector first, and this one and this one. Multiply this and minus this. So here I dou over dou y, z r to the power n minus dou over dou z, y r to the power n. Minus j. Second term is minus this negative sign. So minus j, this cancel, and first row and second column eliminate. First row, second column eliminate, and multiply this to this, cross multiply. So dou over dou x, z r to the power n minus dou over dou z, x r to the power n, plus third again k. Third element is k. So first row and third column eliminating first row and third column. Multiply this to this and to this. Then dou over dou x, y r to the power n minus dou over dou y, x r to the power n. So now here differentiating with respect to y, z r to the power n. Here two functions are in multiply. So we apply here product formula. In this one term, this 2, this 3, and this 4, 5 and 6. There are 6 terms. In each term we apply product formula. So now I common here, Z is constant. I am putting Z as a constant. Differentiation of R to the power n with respect to y. So n R to the power n minus 1 dou R over dou y plus R to the power n constant. Differentiation of Z with respect to y. Differentiation of Z with respect to y always 0. So putting here this result 0. Minus sign. In second term y R to the power n. So y is constant. Differentiation of R to the power n R to the power n minus 1 dou R over dou Z and minus R to the power n. Differentiation of y with respect to Z. Differentiation of y with respect to Z is 0. Y is constant with respect to Z. Z is constant with respect to y. So here this result 0. Now minus j. Minus j. Here is third term Z R to the power n. So Z is constant. Differentiation of R to the power n R to the power n minus 1 dou R over dou x plus R to the power n constant. Differential of Z with respect to differential of Z with respect to x. With respect to x, differential of Z is 0. So here 0. X n R to the power n minus 1 dou R over dou Z minus R to the power n into 0 plus k. Similarly, we apply this formula and we write this step. Y constant, differentiation of R to the power n with respect to x and R to the power n minus 1 dou R over dou x plus R to the power n into 0 minus x constant and R to the power n minus 1 dou R over dou y minus R to the power n into 0. Here putting value of dou R over dou x. So here dou R over dou x is x y r and dou R over dou y is y y r. Dou R over dou z is z y r. After putting these three values here, then we get this is same equation last. This is last equation. Now putting value I z this is y. Here I am writing here y upon r. This is the value of y upon r. So z y and r to the power n minus 2. This 0 minus y z and r to the power n minus 2 and this. After putting we get value this. So now here I and here this result is common. In each term this result is common and r to the power n minus 2 is common in all term. Then we get here this result is common. Here z y n minus y z, z x minus x y and y x minus x y. So this cancel to this cancel to this cancel to this. So here we get n r to the power n minus 2 I into 0 and plus this is minus j into 0 and plus k into 0. So total result is curl r to the power n dot vector r equal to 0. So this problem is proved. Now I want to give some discussion about this problem. We have already solved this type of problem. So I am not solving this problem at this time, but I am giving only some result. Problem 3 based on vector point function f is both solenoidal and irrotational. If number 1 definition of solenoidal. I have solved one problem last lecture, solenoidal and irrotational. So what is solenoidal? What is solenoidal? Okay, this is a question. If vector point function is given in the question, then divergence of f must be 0. This property verified by the vector point function, then that vector function is known as a solenoidal, or del dot f vector must be 0. We have already discussed. So we are finding the vector point function, differentiating with respect to 3 times. So here I dou over dou x plus j dou over dou y plus k dou over dou z. Del dot f vector, this equal to, and here is vector point function, here is dot product here, and vector point function y square minus z square, here y square minus z square, y square minus z square 3yz minus 2x plus 3yz minus 2x and into y, this plus next here 3xz plus 2xy, 3xz and plus 2xy, and this is j plus k. Next here 3xy minus 2xz, 3xy minus 2xz and plus 2z and k vector. Okay, this is vector point function. So now taking dot product here, this I taking dot product with this I, this j taking dot product, this j, this k taking dot product, this k. So I dot I is 1. So finally we write here dou over dou x of x y square minus z square and plus 3yz minus 2x and plus dou over dou y, and this equal to here y with respect to y, j, dot product between j to j. So here 3xz and plus 2xy and plus dou over dou z, dot product between third term k to k, 3xy and minus 2xz and plus 2z. Okay, this problem is this type. So now differentiating with respect to x, y is constant, z square is constant and yz is constant. Only this is 2x. Yes, this is minus 2x. So here is only minus 2. X ka differential 1. Differentiating with respect to y here. X, z constant and differential y is 1. So plus 2x. And differentiating with respect to z. So 3xy is constant. Here z. So minus 2x. And with respect to z. And plus 2. So 2 cancel this 2. 2x cancel this 2. So del f vector, this result 0. Means divergence f0. So vector point function is known as a solenoidal. Okay, solenoidal proved हो गया. Now second point is irrotational vector point function. Vector point function. So we have solved one question, and in a rotational there should be del cross vector f. This must be 0. Del cross f. Del cross f means here I, j and k. I, here writing this x square, y square minus z square plus 3yz, y square minus z square plus 3yz, and next here minus 2x. Similarly, with the help of this determinant, we can find this result is 0. If this result 0, then vector point function is known as a irrotational. Okay, you do this problem self. You find out the cross product between del and f vector with the help of determinant. We have already solved last problem. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.